Welcome. All right, so this here is optimization. This is like saying this is section 4.4. So if you want to add this to the top of the notes, you can. Now, optimization is something that you guys have done before, but you may have called it something else. You may have tried to find out stuff like if you had a river, and here's your river right here, okay, and you're trying to build a coop for your goats, and you know that you have 100 feet of fencing. What is the largest area that you can enclose? And they give you some information, and you found this, found out a maximum, usually by doing some type of quadratic formula, finding the vertex of it, of your equation, and there was your maximum. Well, we're going to that's what optimization is, and this is probably one of the more useful forms of using calculus, and that you'll have, because this is done everywhere in business. This is something that's really well used. So let's take a look at this. Now, I would read this to you, okay, but I think you can read all by yourself. And so I'm going to give this to you. This is something that you can follow while you're doing your problems. I'm going to use this steps, okay, going through this and making sure that the steps, I'm going to show you how this works with all the steps. So here's my first problem. I want you to find two positive numbers such that their product is 192 and their sum of the first plus 3 times the second is a minimum. So for part A, they say to define your variables. Well, a lot of these will have geometric figures. We'll draw a geometric figure, but this one doesn't. So what I want to do is I want to define what my variables are. What are my variables? My variables are two positive numbers. Okay, so I'm going to name it. I'm going to say one's going to be X and one's going to be Y. Well, in this case, I want to be able to say that this represents my first number, because they do mention something about second number, first number, and I want to make sure that it's laid out for me, and I want to label this so that everybody knows what each variable is going to be. And then what I need to do is I need to come up with a primary equation and a secondary equation. Well, how do I tell the difference? Your primary equation is the one that's going to require a minimum or maximum to it. Okay, your secondary equation is usually the other set of information that they give you in order to to make this work. So I look at this one here, such that their product is 192. So their product XY is 192. That's going to be my secondary one. Why? Because it's not asking me to minimize it. However, the second one, where they ask me to find the sum of the first plus 3 times the second, 3 times the second is a minimum. Well, what does that mean? Okay. Well, that means a minimum, well, shoot, this isn't an equation, right? I need an equation. So I need to make sure that this is S. So now I need to make it minimum. Okay, there's my sum. I need to make sure I have a variable here. I need to make sure it's an equation, not just a statement. All right, so now I need to reduce the primary equation to one independent variable. So how do I do that? So what I'm going to use the secondary equation for is I want to input some information from it. I'm going to substitute into this equation. All right, so in order to substitute, I need to solve for one of my variables. I need to solve for a variable that looks reasonable. All right. Well, my variable that looks reasonable to me is saying here, let's see here, I'm going to say X is equal to 192 divided by Y. Solve for that one. And now I'm going to substitute in to my primary equation. And I'm going to say that S, my sum, is equal to 192 over Y plus 3Y. And now notice what I did here. Now that I've done this, now it's all in terms of one independent variable. So that way I don't have to, worry about when I take a derivative, okay, what's happening. Okay. I don't have to, don't have to worry about two variables. In this case, that's now down to one. It makes my life easier. So when we're doing this, now I need to think about my domain. And now when you're thinking about your domain is going to go through many types of issues, or not issues, but renditions, if you will. Okay, so what I like to do to start with is I like to take a look at my actual formula, my summation formula, and say, what is the domain for y? Well, my domain for y says, well, just can't be 0. And then I start taking a look at my other equations and see what makes sense. And so I start taking a look at my other equations. I really can't too much look from here. But I can also say, hey, look, not only can y not be 0, but x can't be 0. Because if x is 0, then I can't have a product of 192. But then I go even further and I take a look at what my problem said. And I go back up here what I circled. And I circled this. 2 positive numbers. So that means not only can y not be 0, y has got to be bigger than 0. Okay? And then they also tell me that x has got to be bigger than 0. There's my domain. This doesn't work anymore. Okay? So let's go over here to the next page. Now my notes are a little bit different than yours. So this is E is really, yours says critical numbers for E. But in order to find my critical numbers, I need to take the derivative. All right, and I'm just going to change this back up so it matches what you have. Okay. So E is my derivative. So I have here S again is equal to 192 over y plus 3y. So I want to go ahead and take the derivative. All right. Maybe to make this easier, I can say that S is really equal to 192y to the negative 1 plus 3y. Therefore, S prime is equal to negative 192y to the negative 2 plus 3. And again, to make my analysis easier, I can make this negative 192 over y squared plus 3. All right, great. So now I'm going to go find my critical numbers. All right, so my critical numbers happen in 2 places. When y prime does not exist, when S prime does not exist, and when S prime is equal to 0. So I break it into those 2 cases. So when does S prime not exist? S prime does not exist when y is equal to 0. But is y equal to 0 my domain? No. So it does not make my list of critical numbers. Next is when S prime is equal to 0. Well, that happens, okay, when negative 192 over y squared plus 3 is equal to 0. I subtract 3, divide by a negative 192, and I get 1 over 64 is equal to 1 over y squared. Flip both of them. I get 64 is equal to y squared. And I get that 8 plus or minus 8 is equal to y. Again, which one do I care about? I care about the positive 8. So my critical number is only going to be positive 8. Then I come over and I do my analysis. My analysis tells me, okay, I take a look at S prime, and my only critical number is 8. But I also have to realize what is my domain for S, for y. My domain for y cannot be less than 0. So this way I have a conscious decision when I choose my test values that I do not go below 0. So I go into S prime, and I plug in, let's say, 1 for S prime, 1 for S prime for the y. When I plug in 1, negative 192 over 1 plus 3, well, that's going to be a negative number. And then what does that tell me? That tells me that from 0 to 8, the sum of my numbers is decreasing. And then I come over and say, well, okay, so what's happening after y is bigger than 8? So let's say like 1,000. So negative 192 over 1,000. Oh, well, that's going to be like a really small number. Plus 3 means it's going to be positive, which means that my sum is increasing after 8. Okay? And so now comes my conclusion. Okay? My conclusion is that since S prime changes sign from negative 2 positive at y equals 8, S has a minimum value at y equals 8. And you might say, well, I'm done. But I'm not done. The question asked me, if I go back to the top, it tells me that I want the 2 positive values. So how do I find my 2 positive values? Well, remember when we had up there that, you know, x is equal to 192 over y, and y was 8. So x is equal to 24. So I put in here at y equals 8 and x equals 24. And that completes my answer. All right? A lot of steps, but they're very deliberate steps. We'll see how it works in this next example. So in this next example, it says here, a manufacturer wants to design an open box top with a square base and a surface area of 108 square inches. All right, so I'm going to make myself a square box. And you're saying, that's a rectangle, mister. Well, here comes my square base, remember? There's that. And do my little dot, 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 dot. Open top, so solid line. There we go. And there's my box. It looks a little tilted, looks a little formed, but let's just pretend for a moment, okay? So I want to be able to find out a surface area of 100 square. What is the dimensions that will produce a box with a maximum volume? Okay, so I'm maximizing volume, so my volume formula is going to be my primary equation. That's why I got to be thinking. And so let's go ahead and name some of our variables. We drew this. I'm going to say that this is S for side length, and this is H, okay, for height. And what I'm going to find out here is I want to find surface area. Again, surface areas are all the areas that I can touch, which means each of the 4 sides. Each side is SH, so I have 4SH plus, okay, then I only have one base, which is S squared, and that's my total surface area, the area that I can touch, and it has to equal 108. And that is going to be my secondary equation. Finally, our next is then I want to maximize my volume. So that means that to find volume, that's S squared times H is equal to my volume. That one is going to be my primary. All right, that's the first step. Second step was finding my equations. Third step now is I need to be able to solve something in my secondary equation and plug it into my primary. The super easy one to solve for is going to be for H. S would be too hard to solve for. So I'm going to solve for H, and when I do that, I get 108 minus an S squared all over 4S. And then I go ahead and find out my volume, and I plug it into my volume. So volume is now equal to S squared times 108 minus an S squared all over 4S. There's my volume. Now I have to start coming over here and I need to think about my domain issues. Well, what's that with domain? Well, things that I should know off the top about just, again, looking at my equation. Looking at my equation, I know that S cannot be 0. Again, I would have a problem with that, okay, volume-wise. Also looking at my equation. All right, also now, okay, let's not look at my equation, but let's also think about it from a real-world perspective. What I know is that no lengths can be negative numbers. So not only S can't be 0 because it would cause a blow up here in this equation, but S has got to be greater than 0. And so does H. H has to be greater than 0. Now you might be thinking, well, what about equal to 0? Well, if I put it equal to 0, again, it doesn't make any sense because I don't have a volume of any type if S or my H is 0. Okay? So what do I want to do now? Well, next I want to be able to, let's see here. Let's take a look a little bit closer. What about volume? Volume can never be negative either. And no matter what I put in for S, any positive value here and any positive value here with my current restrictions will get me a positive number. However, if S squared becomes bigger than 108, then all of a sudden I have a negative value on top and my volume is negative. So I can't have, so S squared, has got to be less than 108. Or in other words, S has got to be less than the square root of 108. So what does that mean for my domain? That means that I know that my domain is stuck for S between 0 and the square root of 108. Okay. And again, the same reason is I can't equal 108, because if I do, square root of 108, then my volume is 0, and I can't have a volume of 0. Okay, I don't want a volume of 0. So then I say here, and my H has got to be greater than 0. There's my final domain. Again, domain is just not simply looking at things. You have to think about it in terms of real world. Okay, so now let's go ahead and take my derivative. So when I take my derivative, before I do that, let's make this look simpler. So I'm going to say that my volume, I can cancel this with this, is equal to, and I can do 108 divided by 4. 108 divided by 4 is 27. So I end up with 27s minus 1/4 an s cubed. There's my volume. Alright, and now I can go ahead and take the derivative of my volume. Derivative of my volume, v prime, is now equal to 27 minus 3/4 s squared. Alright, so next I'm looking for my critical points. So my critical points tell me that whereas v prime does not exist, I look at that and I say, well, v prime does not exist nowhere, so that's, never. So I don't have to worry about that for critical points. What about for v prime equaling 0? Well, v prime equals 0 when 27 minus 3/4 s squared is equal to 0. I solve for that, subtract 24, divide by subtract 27, divide by negative 3/4. And what I get is 36 is equal to s squared, and s is equal to plus or minus 6. So again, I have to think about this and look at my domain. Okay, is 6 work? 6 works. Does negative 6 work? No. So the only critical point is s equals 6. That's the only one I'm going to take. So I come over here and I do my little s prime, 6. And again, I want to put it in my domain. I want to say that I'm going to be between this and the square root of 108. Okay? And when I do this, or when I stick in my values, s prime is, or not s prime, excuse me, v prime. When I choose 1 for v prime, I plug in 1. I take a look at that, plug in 1, and I see that I'm going to have a positive number for v prime. And I plug in something bigger than 6, so I don't know, say 10. 10 still works because it's less than that. Okay, 27 minus 75, it's going to be negative. So that means my volume, so before my side length is 6, my volume is increasing, and then my volume is decreasing. So I do have a maximum there at 6, and what I'm going to do is write my sentence now. And I would say, since v prime changes sign at S equals 6 from positive to negative. S has a maximum, not S. V has a maximum at S equals 6, and we now have to find out our height. So I do that by plugging that in. Okay, so 108 minus that, 24, my height is equal to 3. Okay, so with my side length of S, my height is equal to 6. That dimensions were produced with the maximum volume. Bink. There you go. All right. Now these questions that you guys are going to have on this worksheet are going to be difficult. I want you to do them all, 1 through 5. It means you to think. All right. Hope this was helpful. Talk to you guys later.